This example is to solve a population growth initial value problem, and that problem is p prime equals 10p, and our initial condition is p at time t equals 0 is equal to 0.7. Alright, so let's go ahead and solve this one with integrating factor. So I'm going to rewrite the equation a little bit. I'm going to write it as p prime minus 10p, capital P's, equals 0. And right, if I rewrite it a little more, it's p prime plus negative 10p equals 0. I did that because I want to make sure, right, the formula that we use, if I have y prime is, plus, I'll use f here, not confuse anything, times f of x equals g of x. Then the integrating factor, mu of x, was e to the indefinite integral f of x dx. Right? And so here I want to make sure I have my plus my function in front of the p. And so here we'll have mu, it's t, function of t this time, is e to the indefinite integral negative 10 dt. Right, we can go ahead and solve that. We can do e, that's going to be negative 10t. Right, we can leave the plus constant off the indefinite integral because it ends up multiplying the entire equation. If you need to review that, you can go back to the integrating factor videos. Here we go, let's get going. Now integrating factor, I'm going to multiply to the entire ODE. So we get e to the negative 10t times p prime plus negative 10 times e to the negative 10 t times p. And that equals 0 times e to the negative 10t is still 0. We can go ahead and collapse the left-hand side into this reverse product rule. So e to the negative 10t times p all prime, that equals 0, and I want to leave a little space here. All right, now we can integrate both sides. So integral with respect to t, integral with respect to t. The integral and the derivative cancel, so I get e to the negative 10t times p equals this side, right, I have my constant here, I gotta lump them both on this side, so it's just a constant. Then if I solve for p, I have p of t is equal to a constant times e to the positive 10t. Alright, so now the last thing to do is to solve for the initial condition. So I know that p at time 0 equals 0.7, but that also has to equal c times e to the 10 times 0. But e to the 10 times 0, that's e to the 0. E to the 0 is 1, so c times 1, this is just c. So solving for the initial condition here, we have p of t is equal to 0.7 times e to the 10t. Right, now let's just double check this makes sense. So if we plug in t equals 0, we do get 0.7 out. And another thing is the limit as t goes to infinity, we would expect a population growth, assuming they have unlimited food, right, of p of t. Sorry, let me fix that. Well, that's going to be 0.7 e to the 10 times infinity, and really that's 0.7 times infinity, it's infinity. So that makes sense, right? If we have population growth forever, and they just keep growing and growing and growing, we expect the population to grow all the way to infinity. So yeah, it looks like this is making sense, and it also solves the differential equation, also solves the initial value problem.